Alright everyone, here is your 5.3 example. It says rewrite with rational exponents and solves. We have a is the fourth root of a equals 14. So we can rewrite a, if we say the fourth root is the same as a to the 1/4 equals 14. So if I want this to be a to the first, I have to get rid of the 1/4, which means I need to take this to the 4th power, take this to the 4th power, and we get a equals 14 to the 4th power. Alright, and if you actually wanted to solve it, we could, and that would give us, well, let's find out with the calculator. 14 to the 4th power. So we have 14, remember the caret gives us the exponent 4, and we say enter, and that is 3838416. Okay, so 38416, which equals 38416. Okay, so there is our answer for that one. For part B, we can rewrite b to the 5th, and then the 9th root of that is b to the 5/9 power equals 26. So then how do we do that? How do we get rid of 5/9? Remember, if we have a power of a power, we're multiplying these two things. So if I multiply by the reciprocal of 5/9, which would be 9/5, I'll end up with 9/5. I'll end up with just b, and we'll say that's 26 to the 9/5 power. Well, what is that? Well, why don't we just go and say 26 caret, and then we can do the caret, there we go, 9 divided by 5. 26 to the 9/5 power is 352.33. Alright, we can say about. So we can say b is approximately equal to, was it 352.33? 352.33. Alright, and then here is part C. The third root of c to the 8th power is equal to 47. So let's rewrite this with that rational exponents. We can say this is c to the 8/3 power equals 47. And then how do we get rid of 8/3? Well, if we just multiply this by the reciprocal, it'll give us 1, so we have to take this to the 3/8 power, which means we have to take 47 to the 3/8 power. So let's take 47 to the 3 divided by 8 power, and you get 4.24. Okay, so C is about 4.24. So there is example A. Now if we look at example B, we're looking at point ratio form. And it says if an exponential curve passes through the point x1, y1, and the function values have a ratio b, the point ratio form of the equation is y equals y1 times b to the x minus x1. Alright, so point ratio form, this is going to be a good way to, given some data or given some information, be able to write an equation. Alright, so let's look at example B. Casey hit the ball in the school clock tower. Her pressure reader, held nearby, measured the sound intensity, or loudness, at 40 pounds per square inch. After 4 seconds, it elapsed at 4.7 pounds per square inch, and after 7 seconds had elapsed. Alright, so she remembered from her science class that the sound decays exponentially. So name 2 points that the exponential curve must pass through, find an exponential equation that models the data, and how loud will the bell be when it was struck at 0 seconds. So the first thing is we know that it's exponentially, the sound is decaying exponentially, so we have point ratio form. This also we know that it's decaying, so that tells us that our b value is got to be between 1 and 0 because it's decaying, it's getting softer. Okay, so name 2 points. So the points that are happening is probably going to be time and pressure. So those are the 2 things. So our points, we're going to do part A, I'm going to write it over here, are going to be time, which is going to be 4 seconds, and it's going to be 40 pounds per square inch, so 4, 40. There's 1 point, and the other point is going to be 7, 4.7. So 7, 4.7. All right. So what we have to do is now, let's see if we can find an exponential equation that models these data. So first of all, if we want to use point ratio form, we have to pick a point, and it doesn't matter which point you pick, and then we have to find the ratio, the value b, that will go in there. So let's just for right now say this is our value. Y equals, we're going to say 40 is our y1. We don't know what b is yet, and it's going to be x minus 4. So all we have to do now is find out what b is. We could write another equation actually in the same way, but we're just going to use the other point, right? So I will write that one in red, and I will say y equals, instead of 40, we have 4.7. We don't know what b is, and it's going to be x minus 7. Alright, so now what we're going to do is, if we want to find out b, we can actually say we know that at any point these 2 equations mean the same thing, so I'm going to write the following. 4.7 times b to the x, oops, I said to the x minus 7. I want it to be b to the x minus 7. We're going to say that equals our other equation, which is 40 b to the x minus 4. Okay, so now what we're going to do is, let's say we want to really solve for b. So that means what I'm going to do is I'm going to divide both sides by 4.7 because I want to get the b's on one side. So I'm going to divide by 4.7, divide by 4.7, and we get 40 divided by 4.7. 40 divided by 4.7 gives us 8.51 about. Okay, so we're going to say this is over here on the right side. It's going to be I think we said 5.7, right? 8.51. 8.51 about, and then that's going to be times b to the x minus 4. And we're going to be left with on this side is going to be equal to b to the x minus 7. Alright, so now what I want to do is I want to divide both sides by b to the x minus 4. Divide by b to the x minus 4. Alright, so then if I'm dividing these bases, I can say that's the same as b to the x minus 7, and it's going to be minus the denominator, which is x minus 4, and we can say that whole thing is going to equal 8.51, right? Approximately 8.51. So now if we're going to do that, we're going to subtract both of those. So x, it's going to be x plus x. So we're going to end up with this is going to be b. X minus x gives me nothing. Negative 7 minus a negative 4. So negative 7 minus negative 4 is really negative 7 plus 4, which we can say is b to the negative third equals 8.51, right? So now if we take this to the, if we want to do it this way, negative 1/3 power, take this to the negative 1/3 power, then we'll end up with our answer, and let's see what we can do. So we can take this number, and instead of writing out 8.51, we're just going to take this. If I just do the caret, it's going to say answer to the negative, we said 1/3 power, so 1 divided by 3, and we get 0.489. So let's say 0.49. Okay, so we're going to say B is about, what was it, 0.49. 0.49. And we did say it had to be between 0 and 1, so that's a good sign. 0.49. So our equation, we could then say, is y equals. It doesn't matter which point we choose as long as we choose one of them, and we're going to use, we have our new b value. I'm going to choose the one in blue. So it is y equals 40, 0.49, and that's to the x minus 4. Okay, and then how loud was the bell struck when it was at 0 seconds? You just plug in 0 and then evaluate everything. Alright, so that means it's going to say y equals 40 to the 0.49 to the negative 4th. So we can take this number, and I know that because I'm taking this number, it might be a little bit different than if you just type in 0.49, but this to the negative 4th, so I don't want to do that. I want to have negative 4th. Okay, so we take this number to the negative 4th, gave us the value right here, and then now all we have to do now is multiply it by 40. So we multiply by 40, and we end up with 695. So how loud was it? We can say about 695 pounds per inch squared. Alright, so there is your example B. And that's parts A, B, and C.